All right, welcome to the second half of 6.1, 6.1.2. And we're continuing to complete the square and go through a few more examples in here. So our first full example is about completing the square. We want to rewrite the standard form equation y equals x squared plus 8x plus 5 in the form of y equals ax minus h all squared plus k, which again is called the vertex form. And this one is standard. Then we're going to write the coordinates of the vertex of the parabola. So we know that because in vertex form, the point of the vertex form is that h and k then become your vertex. Then we're going to sketch the graph of the relation. So going back to chapter 4, we're going to label the vertex at the axis of symmetry and two other points on the graph in order to properly graph it. So again, we're starting off with our algebraic tiles just to have the visual of what we're actually doing, and then we'll go through the algebra as well. So we've got 1x squared and 8 tiles. So again, we're taking our b term because we've got y equals ax squared plus bx plus c is our standard form. So our b term is this 8 here. We divide the 8 in 2 to have 4 here and 4 here. That's our dividing by 2. So we know we've got x plus 4, x plus 4 on there. But our ones don't match up. We've got 5 ones. And in order to have a perfect square trinomial, we need to have our b term divided by 2 squared, which ends up being 4 squared, which of course is 16. So we need 16 ones in place in here. I'm not going to draw 16, but we need 16 ones in there. And then of course what we need to do is to even that out by having negative ones on the other side. So algebraically again, we want to separate into two groups, one section and the other section. We want to figure out how many ones we need in order to make a perfect square trinomial. And then we need to both add and subtract that number. And it makes it easier for the future questions if you leave it inside the bracket, but you can also then you then have to take it outside the bracket. So that extra step will help you remember what to do in a few moments. Remember that we're then subtracting. If we put that into another bracket, we're going to end up multiplying instead of subtracting. Now we know, I won't take you all the way there. So now we've got 16. So we've got 16 units. So to complete the perfect square, you need to add 16 unit tiles. In order to preserve the original quadratic expression, you must also add 16 negative tiles. So these are positive tiles, which will go in there to complete our square. These are negative tiles, which will be added and subtracted from our 5 original tiles. So algebraically, we cancel these ones out. Positive and negative makes 0. And we see what we're left with. So we have our perfect square trinomial, which again, x plus 4, 4 plus x plus 4. We end up with x plus 4 squared And what we've got left over, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 negative squares. So using the algebraic tiles, we can see once we cross off what's left over and add up what's still there, we've got 11 negative tiles. We know we've got x plus 4 and x plus 4, which is x plus 4 squared, and now we have reached the format of our vertex form. So if we're going to do all of that algebraically, I already started it and then stopped it. We start off by putting our a and our b term in brackets. We put our a and our b term, just put brackets around them like that. Then we need to figure out, when we're looking at what's inside the brackets, how can we make this a perfect square trinomial? So step 2 is to take the b term, divide it by 2, and square it to find what we need to make a perfect square trinomial. So in this case, we have 8 divided by 2 squared, which again we said was 16. So now we need to both add that and subtract it. And since we don't have an a term, it really doesn't matter if you put that inside or outside the bracket to start. Once we have an a term, I want you to write it inside the bracket, and then we can move it outside the bracket, and you'll see how that works in a few minutes. But remember that subtraction sign. That's where some people are going to fall down, is they're either going to try and make that a positive or they're going to try and make that multiplication. Don't do that. So now we know, because we are using our a squared plus 2ab plus b squared equals a plus b all squared. Using that for what's inside the bracket, we can just jump down to, and we've already got that number right over here that we know we're going to be dealing with that 4. We've got x plus 4 squared, and then we just figure out what's left over, minus 11. So this is our rewritten form. We've got it both algebraically and with the tiles. If you're not understanding the tiles, again, that's not as important as understanding how this worked algebraically. So I guess I need to finish my steps. Step 3. Both add and subtract whatever becomes of b divided by 2 squared. Step 4, complete the square, which is what's happening inside that bracket. So that is right there, going from there to there, that's completing the square. And then if you want to put it in step 5, simplify outside the bracket. And just enough space. So a textbook writes it like this. Again, same steps, but just they do it a little bit differently. So rewrite the relation in the form y equals ax minus h all squared plus k by completing the square. Again, put brackets around a and b. Group the first two terms, is how they put it. To make a perfect square trinomial inside the brackets, add the square of half of 8, which is 4 squared. To balance the equation, also subtract. So we've got this adding and subtracting. Take the negative 4 squared outside the bracket, and why we've got that in a separate step will make sense in the next example. Factor the perfect square trinomial and simplify. So basically exactly the same. So now we want to write the coordinates of the vertex of the parabola. So we know our regular equation is y equals a x minus h all squared plus k. So take a second, pause it if you have to figure out what the vertex is before I give it to you. So we know that h, there's a negative here, so whatever is in the h place needs to be the opposite sign. So we end up with negative 4 and negative 11 as our vertex. Because our k is going to stay the symbol that we see, but our h is going to switch because that is a negative in the original equation. So our vertex equals negative 4, negative 11. And how are we going to graph that? So start with the graph. Make sure we are labeling at least 1, 2, 3 so that we know how, and put them right on the lines. Some people like to put them between the lines and then they could get confused which line is which. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm a little bit off. So my vertex is down here, because this would be negative 11 just off my screen. Now, just because I have my vertex doesn't mean that I can instantly graph. So we need to know some other things. So label the vertex, I know that. Axis of symmetry. Axis of symmetry, A of S, always equals the x in vertex. So if our vertex is negative 4, negative 11, our axis of symmetry equals x equals negative 4. So always put x equals negative 4. We've been not doing that as well as we should. So our axis of symmetry is going to be in green. We know that. That's our symmetrical point. Now we need to find a couple of points on this graph. So we have our equation. So we need to find a simple point. So a simple point would be our y-intercept. Now I already know our y-intercept because we know that our y-intercept is going to be 5 because c equals the y-intercept. But I'm going to show you, prove that by doing it through the other equation. So if we are talking about our y-intercept, which of course is, this is y, so where is it going to pass through y? Of course, our x is going to equal 0. So we're going to do it. We want to find y. X is going to equal 0. And we'll just do our algebra. 16 minus 11, y equals 5. So we already knew that because if we remember from the very beginning of chapter 4, we talked about that. Otherwise, you can figure that out like that. So we know we're going to pass through way up here. Yep. So we could also use our up and over strategy that we also do as so our pattern there, but this book have asked you to do it like this. So now we know that we've got 1 point, so let's label that. And because this is a line of symmetry, we know if we went over 1, 2, 3, 4 spaces in that direction, we want to go 1, 2, 3, 4 spaces in this direction, and we have a second point of -8 and 5. So now we can just, using this technique, kind of sketch in our parabola. Another technique that we know that would be even more accurate would be to use our pattern and know when we go over 1, we're going to go up 1. Then we go over 1, we're going to go up 3. Over 1, we're going to go up 5, 2, 4, 5. So I didn't draw it exactly right, but not bad for a sketch. I should be pointing right there. Over 1, up 7, 2, 4, 6, 7. Obviously, there's there. So that is a more accurate drawing of our sketch, of our parabola, using the patterns that we've known from past chapters. It's not the way they're asking for it to do here, but our up and over pattern of 1, 3, 5, 7, because we do not have an A term. So because there is no A term, we can just use that pattern as well. If there was an A term, again, we would multiply that by the A term. But since the A term is just 1, there's nothing before x squared, there's nothing before our vertex or our brackets there. We know that we've just got an x squared term. So that is labeling. So we've done everything. We have labeled the vertex. We have the axis of symmetry. I could even write that in, x equals -7. And 2 other points in order to draw our vertex. And that's how the textbook put in the answer. So you could do it from here. That's proof that this is y. C equals the y-intercept, because when we have x being 0, it's going to make both of those terms 0. And then due to the symmetry, we know that we can count in this direction by 4, we're going to count in that direction by 4, and we're going to get -8. Okay, problem 2. Find the maximum or minimum point of the parabola. So this one is going to be different because now we have a x term. Or we have an a term, I mean. So maximum or minimum point, what does that mean first? Our maximum or minimum point, think about that, pause it for a second, see if you can remember what that means, is the top or the bottom of our graph. So these are our vertex. So our maximum and minimum point is the vertex. So really they're asking us to find the vertex. So of course we're going to have to complete the square in order to do it. Oh, I want me to do it on here. Okay. So we need to find our vertex. So now it gets a little bit more complicated, because now we've got an A term to deal with. So now before we start the steps that we were doing before, we need to deal with this A term. So still, we want to bracket A and B terms. But now we need to get rid of that 2. So in order to get rid of that 2, we need to factor it out. So I'm going to divide both terms by 2 to factor it out and put it on the in front of the bracket, same as I've done in a whole bunch of different styles. So now that 12 becomes a 6, that 2 becomes a 1. We've divided both terms by 2. The 2 is on the outside of the bracket. So divide out a term. Now we're going back to our normal 1. So we still want to consider this the b term. We still want to go b divided by 2 all squared, which is 6 divided by 2 all squared, which is 3 squared, which is 9. Then we want to, of course, add and subtract. Here's where it gets complicated again. Keep it inside the brackets. Plus 9 minus 9 inside the brackets. Because that isn't just a 9 in there. It is a 9 times 2. Because everything that's inside that bracket is multiplied by 2. Remember, we need to distribute to every term when we go back in. So we can't just think of that as a 9. We need to think of that as a 9 times 2. So this is 9 times 2. So when we pull it outside the bracket, it's not just negative 9, it's negative 9 times 2. So our next step so that 9, whatever number that b divided by 2 squared is, I'm just saying 9 here, but whatever that b divided by 2 all squared number is, needs to be multiplied by the a term and put outside the brackets, remembering that it is a minus. So let's see what that looks like. So everything else stays the same, but now I'm going to go 9 times 2 equals negative 18. Negative 9 times 2 equals negative 18. Minus 18 plus 11. Remember that we are minusing. Don't change the sign. Don't make it a multiplication. We are just pulling that outside the bracket, multiply it by the a term, multiply it by the a term, and bring it outside the bracket. Now it looks a lot more like our last ones. We want to complete the square inside the brackets. Again, if we aren't following that, you need to go back a lot of lessons because we've been doing this a lot. That's why I said make sure you understand these rules. So that's how we've gotten from up there to down there, all squared. And then simplify the outside. So negative 7. So complete the square and simplify. So rewatch that again if you aren't understanding how that works. This is how this book puts it. Again, pause. I need to finish this before we start our class, so I've got to go a little faster. Pause, read what they're saying, see if it makes sense to you. And then in the end, use Desmos to check your answer. So look at your two formulas, ax squared plus bx plus c, and your y equals ax minus h squared plus k. Two formulas, put both of those into, so your beginning and your end, into Desmos to make sure that they are in fact the same graph. If you're not getting the same graph, you've done something wrong, so use Desmos as a check. Example 3, the path of the ball. So this one's the same as the last one, except instead of a 2, we're getting a negative. So the path of the ball is modeled by the equation y equals negative x squared plus 2x plus 3, where x is the horizontal distance and y is the height. So basically we've thrown a ball in meters above the ground, so they're both in meters. What is the maximum height of the ball, and at what horizontal distance does this occur? So what are we asking there? What is the max height? We want to know how high it is at that point and how far from the throwing did it reach that. So really what we want to know is our vertex. If you're confused with the question, it's probably asking you for the vertex. So at what maximum height? So our maximum height would be y. And at what horizontal distance? So horizontal distance is our x of our vertex. And then we're going to sketch it. What is the maximum height of the ball and at what horizontal distance? So first we need to complete the square. So again, we have an a term that's not 1. It's negative 1. So we've got to follow the steps we did a second ago. So we want to first of always bracket our first 2. Then we want to pull out this negative 1. Or divide it out. So everything's going to be divided by negative 1, which really just changes our signs. So we end up with negative 1 outside the bracket. We end up with x squared minus 2x inside the bracket. And a plus 3 outside the bracket. Then we need to complete our square. So we take our b, which is now a negative. Negative 2 divided by 2 all squared, which is negative 1 all squared, which is 1. We want to use that to add and subtract, again staying inside the brackets. We're going to add 1 and we're going to subtract 1. To even that out. Now we're going to bring this negative 1 outside the brackets, but remembering that we need to multiply it by our a term. So negative 1 times negative 1 equals positive 1. So we're changing the sign when we pull that outside of the bracket. Again, I put the Khan Academy and a couple other videos to practice with this. If you are not following me, there might be someone else that explains it a way you like it better. So negative 1 times negative 1 is +1. Remember to put in that positive sign. We want to make sure that you remember that we are adding here. Oops. Now we want to complete the square inside the bracket. And now we've got -1. Checking that. Yep. Because we also got our a squared minus 2ab plus b squared equals a minus b all squared. So that's our second one. And make sure that you remember both of those. It caught me for just a second. I had to go look. And simplify our outside, +4. So now we know the vertex. Again, K and H, opposite signs for K, normal signs for H. Our vertex is going to be 1, 4. So what does this mean in terms of our ball? We want to know the maximum height of the ball and the horizontal distance. So our X and our Y, X is always horizontal distance, Y is always going to be height. So the max height is going, and we were working in meters, so is going to be 4 meters. And our distance is 1 meter. So after 1 meter, it is 4 meters high. So we've thrown it up a bit. It's coming down. Our max height is 1, 4. So same thing, but computerized. Again, we end up with the same answer, -1. Oops. Yep. Taking my answer to their answer. There we go. So again, pause, read through what they want to say, and see if that makes more sense. So since we know the vertex, we know the max height of the ball is 4 meters after it's been thrown a horizontal distance of 1 meter. Graphing this. So again, we know the vertex is +1, +4. Let's do 2 squares. 1, 2, 3, 4. 1, 2, 3, 4. So we know our vertex is 1, 4. Again, we know our y-intercept is 3 because it shows up in there. We know our axis, oops, sorry. We know our axis of symmetry is right there. So we also know we have a second point right there. So we can figure it out using our 1 to 3, or our 1, 3, 5, 7 pattern, but it's just asking us to kind of draw it in here. So really we'd be standing up here, we threw the ball, we were standing up here on a fence, we threw a ball, it got higher and then it got lower, and that's the path of our ball represented in our vertex. All right, I gotta get ready for our class. So again, pause, read through how they've done it. Then I've got practice questions for you. And I've actually got the answers as well. except for number 5, so that just like the back of the book, you know what you're doing. So the expectation is that you will complete these 5, showing all of your steps, showing all of your work, and uploading them onto Google Classroom. All right, that's the end of